Now we are talking about the SAMA5D3. So this presentation will be the technical overview of this brand new series based on the Cortex-A5 core. So I don't know if you are already familiar with the Cortex-A5 core, but as a first part of this presentation, I will do an overview also of the core itself, and I will position it versus other ARM cores, such as the old ARM9 and ARM11 cores, or even the other Cortex-A core available in the market, such as the Cortex-A8 and A9. Then I will come back on the product itself, so I will describe the system architecture. Then I will talk about the memory support. As you will see in my presentation, we improved many features which allows to support more types of memories. Then few words regarding the security. I will just remind the main features related to security. The Atmel secure boot will be more detailed in another presentation. Then some application-specific features will be detailed regarding connectivity, user interface, so or even control features. So regarding connectivity, the main point to highlight is the new Ethernet controller, which supports gigabit. So the gigabit Ethernet controller, which is called GMAC, is also a brand new feature introduced on the SAMA5D3. Then regarding user interface, we will highlight the new features available on our LCD controller. And for control features, we will talk about the ADC more in details. The last part of my presentation will be dedicated to our current hardware and software offer. If you have any questions during my presentation, just raise your hand and I will be pleased to answer. So do not hesitate to interrupt me. Okay, so let's start with this technical presentation. As you can see in this first slide, with the SAMA5D3, we extend our current MPU portfolio. And as you will see later in my presentation, the Cortex-A5 core is the perfect migration for ARM9 or even ARM11 users. So obviously this brand new core gives you more performance. As you can see on top of this slide, you are able to achieve more than 800 MIPS. Okay, so there is we provide much more performance compared to our previous ARM9 based products. The CPU frequency, for example, of the SAMA5D3 is up to 536 MHz, and on the previous generation of ARM9 based products, the maximum clock was only 400 MHz. So I will also give you more details about performance improvements later in my presentation. We also improved the feature set. So we have now a DDR2 controller with a 32-bit data path. This is new. As I said in my introduction, we implemented the new gigabit Ethernet controller, so more performance when using an Ethernet port. And also, we implemented with the Cortex-A5 core the floating point unit. This is an extension of the Cortex-A5 core. So more performance, but still the ideal migration path for SAM9 or ARM9 or ARM11 users. So what's new with the Cortex-A5 core? As you may know, this Cortex-A5 core is based on the latest ARM architecture, which is the ARM v7 architecture. This new architecture introduced new instruction set. So I guess most of you are already familiar with Cortex-M cores. So this is the same version of the architecture. So you will, on the Cortex-A5, you will find also the FUM2 instruction set. And also, as I said previously, the floating point unit, VFPU. This SAMA5D3 gives you more performance. As I said, we increased the CPU frequency up to 536 MHz. The bus speed was also increased up to 166 MHz, so more performance with this product. But the main key point I would like you to understand in this presentation is that in terms of pure performance, we are not, the target of this product and the target of the Cortex-A5 core is not to compete with other Cortex-A cores, such as the Cortex-A8 or A9, which can run above 1 GHz. Of course, we cannot compete with them, and our target is not to go with this product in the high-end applications such as smartphones or tablets. Our target with the SAMA5D3 is to go on application which needs power efficiency. So what is power efficiency to me? Well, this is the processing power per milliamps or per milliwatts. Okay. So as you will see in the next coming slide, we have very low power figures for such kind of product, and in ultra low power mode, the power consumption is below 1 milliamps. So this is something quite important to remind. Okay, the focus of this product is power efficiency. And as you will see also later, if we compare the power consumption with competitors or with our previous ARM9 based product, we are slightly lower with the SAMA5D3. Again, we bring more features with this product, or we increase the level of performance. You've got a gigabit Ethernet controller, 2 CAN ports, an high-end LCD with a 5-layer overlay, and with post-processing controller. This is also something new on our ARM MPU. And we also provide a new version of our DDR2 controller, which has a 32-bit data path. Another new feature, which is quite important, is the support of low power DDR and low power DDR2 memories. We bring also more security with this product, thanks to the secure boot with key storage. So again, this new feature will be commented in another presentation. We have an embedded encryption engine supporting AES, SSS, and SHA, and also a true random number generator. So those are the main key points to remind. The SAMA5D3 comes in different derivatives. So you've got 4 different derivatives. They are all pin-to-pin compatible. Okay. So as you can see, you can have as an option the two Ethernet ports. So the standard Ethernet port, which is quite usual on our MPUs, and the brand new GMAC, the gigabit Ethernet port. Okay, so on the SAMD35, the LCD controller is also implemented as an option, but all derivatives are pin-to-pin compatible. So the SAMA5D3 fits to a broad range of applications. So I will not comment in detail this slide, but basically the SAMA5D3 is the perfect candidate for human-to-machine interface and control panel, thanks to the improved DDR2 controller, for example, thanks to the high-end LCD controller, and also thanks to the integrated floating point unit for accelerating graphics processing. It's also the good candidate for networking application and the gateways. Okay, you've got the gigabit Ethernet port and also the standard Ethernet port, which can be added to the first one on the SAM A5D35, for example. You've got a high bandwidth architecture. I will detail the architecture later in my presentation, and also the encryption engine to secure communication. In addition, you can also use this product for imaging and terminals or battery operated application. As you can see in this slide, and you will also have more details later in my presentation, this chip is designed for application who need power efficiency. So this is a really good product if you want to run an application using batteries. We already have customers who design their application using the SAMA5D3. So what was the winning factors we identified? So at first we have a customer who used the SAMA5D3 in his low-end oscilloscope for patient monitoring. So this is a medical application. So the winning factors for this application were first the processing power, okay. Then also the features embedded in the LCD controller and the Linux and the Auto support. As you may know, we provide our free Linux distribution, but I will comment this later in my presentation. You will also find the SAMA5D3 in an ARM system. So the secure boot and the hardware encryption engine will be used in this kind of application, and also the dual eMAC, okay, for network communication. Finally, you have you can find SAMA5D3 on the barcode printer and also on the battery operated application, which is a smartwatch for an outdoor GPS. This slide made a comparison with our previous high-end product, okay, which is quite popular today. So this high-end product is the SAM9G35, so based on an ARM9 core, okay. And as you can see in this slide, the SAMA5D3 is a kind of super G45, I would say. So it brings more performance. 1.57 dBs per megahertz versus 1.1 only on the G45. The bus width has been also increased from 32-bit to 64-bit, so more bandwidth, more performance again. And we also improved several features such as the DDR2 bus width, the LCD controller, the Ethernet performances, and so on. We also added the encryption and the secure boot. And as you can see in this slide, in ultra-low power mode, we slightly reduced the power consumption. It was 12 milliamps before on the G45, and now it's below 1 milliamp. I think that's it for my introduction. So let's now have a look more in detail on the Cortex-A5 core. So I will just talk about the different features available on the Cortex-A5 core by making some comparison with other Cortex-A and other old ARM processors. And then I will give you more information about the implementation of the Cortex-A5 core we made on the SAMA5D3. So first point of this slide, most efficient Cortex-A core to date. So I don't know if you know this, but the Cortex-A5 core is one of the latest Cortex-A developed by ARM. In other words, it's much more recent than the Cortex-A8 or A9. So we benefit from many improvements made by ARM regarding features. Okay, so this is something quite important to remind. The main idea or the way how ARM position the Cortex-A5 core in this portfolio is that it's a migration path for ARM9 and ARM 11 users. Okay, they wanted to keep things relatively simple if we compare to the Cortex-A8 or Cortex-A9 core in terms of debug, in terms of internal architecture. The Cortex-A5 core is much more simple. Okay. But still, there is no compromise in terms of performance, as you will see in the next coming slide. So the Cortex-A5 core has an optional floating point unit or an SIMD extension, which is called Neon, okay, for media or signal processing. It also has the multi-processing capability. You can implement up to 4 processors, and the applications are fully compatible with other Cortex-A architecture and classic ARM processors. Let's compare now the Cortex-A5 core with other ARM architecture. So as I said in introduction, and as you can see on the left of this slide, in terms of pure performance, we are not competing here, obviously, with Cortex-A8 or A9 core, which can run above 1 gigahertz. Okay? And again, what is the main strength of this product is power efficiency, okay, which is the processing power per milliwatt. So here you've got milliwatt per megahertz, so smaller is better. Okay? And as you can see, the Cortex-A5 is slightly better than any other ARM processor. So you have better performance than ARM9 and ARM11, and less power than an ARM9, and slightly less power than also an ARM11, Cortex-A8 or Cortex-A9 core. In terms of core area, this is basically the same as an ARM9 core. As I said, the Cortex-A5 core surpasses the ARM11 in many areas. We benchmark this core using the EMBC benchmark or the SpaceX 2000 benchmark, which is a benchmark allowing to compute the processing power with integers. Okay, and we have slightly higher performance level if we compare to the ARM11. And the Cortex-A5 also at least equals or surpasses the Cortex-A8 in many areas. We've got the same performance level on the SpaceX 2000 benchmark. We tripled the performance on floating point operation, and also, of course, we can implement up to 4 cores with the Cortex-A5 architecture compared to 1 core on the Cortex-A8. So power efficiency, but still no compromise on pure performance. Again, power efficiency, this is the main idea here. And as you can see in this table, again, the DMIX per milliwatts, the Cortex-A5 is the winner here. If we compare to the Cortex-A8, we have 8.5 DMIX per milliwatt for the Cortex-A5, compared to only 3.8 on the Cortex-A8, and 3.6 or on ARM11 or 4.9 on ARM9. So Cortex-A5 is the champion for power efficiency. Okay, let's move on to the architecture. So a few words regarding the architecture of the Cortex-A5. It's based on another architecture, and it has a 64 kilobyte cache, so 32 KB of data and 32 KB for instruction. The Cortex-A5 core comes with a 64-bit IXC matrix. You will see later how we implemented the matrix and how we connected to our peripheral bridge. And again, the Cortex-A5 has good performance, even very good, I would say, performance, so up to 1.57 MIPS per megahertz. So again, if we compare to Cortex-A8 or A9 core, this is quite, the architecture is quite simple and much more easier to debug. This is almost the same, I mean, it's the same philosophy as ARM9 or an ARM 11. I will not go too much in details on the pipeline, just know that it's, the pipeline is an 8-stage pipeline. So basically you got 3 stages of prefetch, 1 stage of decode, 1 stage for issue, and 3 stages for execution. To finish with this overview of the Cortex, yeah.
What was the last execution part?
Yeah, depending on the instruction you execute, you get 3 different backend
What is Alice?
Load and store.
Ah, okay.
Okay. So just to finish with this part, on the Cortex-A5 core, this table you can see in the slide just summarize how we implemented the Cortex-A5 core on SAMA5D3. So there is only 1 processor. Okay, as I said, you can implement up to 4 processors, but there is only 1 on the SAMA5D3. The floating point unit has been also implemented. It's optional. The memory management unit is also present on the SAMA5D3. We did not implemented the Neon, the SIMD extension in the product, nor the embedded trust module. Okay, this is not available on the SAMA5D3. Regarding security, ARM provide their own security features and security mechanism. They call it the trust zone. So we decided to keep our own security features, so we did not implement the trust zone. And this is the same for power management. ARM proposed to their customers to implement their own energy management, so IEM, but we decided to keep our low power modes and clock management mechanism. Do you have any question?
When you do a dual core implementation, from a software point of view, is there something that the customer needs to do to manage the dual core, or does the hardware manage everything?
This is a good point. I think there are some software stuff to do, but to be honest, I'm not really familiar. Yeah. That's a good point. But to be honest with you, I'm not really familiar with dual core because we don't have products with dual core for now. I mean, can't use.
Yeah. The big question is, anyway, would it be beneficial to have the dual core in the core on the A5, or would it be not easier and more beneficial in terms of performance connection to using A15, for example?
Yeah, this is a good point. The marketing is investigating on it currently, so yeah, this is the big question is that is there any need in the market for such kind of application? To be honest with you, I'm not sure today, so difficult to answer.
Because there's a difficult niche as the flash plates gets used for bigger and bigger.
Yeah.
And you have a lot of applications that are able either to go to a flash-based system or directly have enough resources in terms of power and big batteries using A15 or A9. So this is a very special mix between power and power efficiency and reality.
Yeah, this is something.
I think it's quite obvious actually. The voltage is followed by both the must be really by the
So let's continue with the system architecture of the SAMA5D3. So this is the block diagram of the product. I know it can be quite complex to understand, especially if you are not familiar with really familiar with our block diagram. So I will not comment everything in details. Okay, I will simply highlight the main new features and the key points I already highlighted in my presentation. A few words regarding the memories. So there is nothing really new regarding the ROM in orange in this slide. Okay, I don't know if it's clear for everybody, but basically we find the exact same features you had on our other MPUs. So you still have SAMA boot and the non-volatile memory boot application. So you will be able to boot from a data flash, serial flash, SD card, non-flash boot, or any square core. So this is there is nothing new here. You got two banks of SRAM, two external bus interface. So the first one, which is the DDR2 controller, is now 32-bit data path. This is new, and you have another external bus interface at 8 or 16-bit if you want to connect a non-flash, a PS-RAM, a non-flash, or even an FPGA. Okay. So two external bus interfaces. The Cortex-A5 core, as I said previously, comes with a 64-bit matrix. So this is what we call the AXE 64-bit matrix in this slide. So basically we connected this matrix to our multi-layer AHB matrix connected to the peripheral bridge by using AXE AHB or AHB AXE bridges. You can see here and there. Okay, so those bridges are embedded FIFO. So this is also something new. On the previous products, the bridges didn't have such kind of FIFO. So this increased the overall bandwidth available in the product. In terms of peripherals, two DMA controllers, so 16 channel, to perform memory to peripheral to memory, or memory to memory transfers. Okay, for those who are familiar with our product, there is no PDC here. Now this is all handled by the DMA controller. LCD controller with a dedicated FIFO and a dedicated DMA channel. This is the same for the GMAC and the standard eMAC, so the Ethernet ports. There is a dedicated DMA channel. I will not comment in details all the different peripherals available. Simply note that we introduced with this product, and this is the very first product with this peripheral bridge. So as you can see here, we introduced the multi-frequency peripheral bridge. So thanks to this bridge, you will be able to change the frequency of the CPU, I mean the clock of each peripheral individually. Previously on our other MPUs, as soon as you enable the clock of a peripheral, the peripheral of this clock, the clock of this peripheral was equal to the frequency of the master clock, MCK, and you had no choice. Now with the multi-frequency peripheral bridge, you have the possibility to decrease by a power of 2 of MCK the frequency of the clock for each peripheral. As you can understand, this helps to reduce the overall power consumption of the device, and it gives much more flexibility.
What is the SMD?
It's a soft modem.
Oh, the soft modem.
Yeah. You remember?
Yeah.
You had the same on the SAMA5D3X series. So it's an IP provided by Connexa.
Just on the LCD controller and the GMAC,
Yeah.
You mentioned DMA there. Does that just mean it's DMA enabled, or does it have its own dedicated DMA channel?
Yeah, dedicated.
Okay. So basically you have 60 channels of DMA plus those channels
Yeah.
dedicated to that.
Okay, so let's move on to the different power supply. Again, I will not comment all the different power supply sources. Okay, this is quite usual on our MPUs. The only new feature is the introduction of VDD fuse. So VDD fuse powers what we call the fuse box. So this is a set of one-time programmable bits. Okay, all those bits are related to security features. So I will comment it later in my presentation. So this is the only new thing about power supplies. This is just not that VDD fuse is 2.5 volt, which is quite unusual on our product. So this value is mainly because this is a TSMC technology. That's why it's 2.5 volt. Okay. If a customer don't need to write those fuses, VDD fuse can be left floating. Okay, if you just want to read, there is no need to connect VDD fuse. Few words regarding the power-up sequence. One of the main also strengths of the product, if we compare to competitors, is the power-up sequence. We wanted to keep, again, things simple here. The power-up sequence given in this slide is quite simple. As you can see, you just need to establish VDD-IO first, so VDD-IO-P and VDD-IO-M, then VDD-PLL, and at last VDD-Core. There is no need to have a companion chip, which can be quite expensive, to power up the device. If you have a look to the schematics of our evaluation kit, which are available for free on our website, by the way, you will see that our power-up sequence is based on two different regulators, and the whole cost of the power supply is below $1. This can make a big difference if you compare to competitors, so running Cortex-A5 or A9 core, which needs a PMIC to operate. The overall cost can be up to $2 or $3, and for us it's below $1. So this is also something customer has to take into account when choosing his microcontroller. This is something quite important. To finish with the power supply, I would like to share with you a few information regarding operating point versus power supply. So basically, on the full power range, so between 1.08 volt and 1.32 volt, the core frequency can be up to 400 megahertz, and the bus frequency is 133 megahertz. Okay, so this is on the full range of VDD core. If a customer can guarantee 1.2 volts minimum on VDD core, then the core frequency can be increased up to 536 megahertz. The bus frequency is up to 134 megahertz in that case. So this is only if the customer can guarantee 1.2 volts minimum on VDD core. Then you can also increase the bus frequency if the customer can guarantee 1.2 volts minimum on VDD core and 1.75 minimum on VDD-IO DDR. In that case, the bus frequency can be increased up to 167 megahertz, and the maximum core frequency in that case is 500 megahertz. In this configuration, and as you can see in this table, we lose the low power DDR and low power DDR2 compatibility. mainly because of internal timing violation. So we violate the timings specified in by the LPDDR specification. So you just need to be aware of that. Regarding power consumption, as I said previously, several times, this device has very low power figures. Okay, so let's have a look on it more in details now. So as you can see, the power consumption at 400 megahertz, so in active mode with all peripheral enabled. Okay, the power consumption is 88 milliamp, as you can see, and in the maximum processor clock, so 536 megahertz, the power consumption on VDD core is 110 milliamps maximum. Okay. In low power mode, in idle mode, so in idle mode, the core is just stopped waiting for an interrupt with all peripheral clocks disabled. The power consumption on VDD core is down to 19 milliamp. In ultra low power mode, down to 0.3 milliamps. So in that mode, the clock of the core is 500 Hertz, and all the peripheral clocks are disabled. And in backup mode, which is our lowest power consumption mode, the device is only powered by VDDBU, so all the other power supplies are off. And in that case, the power consumption is down to 1.2 microamps only, and on VDDBU, because as I said, VDD core is off, so no power consumption on VDD core in that mode. So nice figure, but let's compare it to our other MPUs. So we made a comparison with the SAM9G45 and the SAM9X35, which is the most recent SAM9 based product we introduced in the market. And as you can see, in active mode, we slightly improved the power consumption. So at the same frequency on the bus and on the processor, 88 milliamps only on the SAMA5D3 versus 130 milliamps for the G45 or 109 milliamps on the X35. The difference is quite huge also in a low power mode. So in idle mode, we have 19 milliamps, as I said previously, on the SAMA5D3, and we had previously 55 milliamps and 38 milliamps on the G45 and X45 respectively. The difference is also huge on the ultra low power mode, so 0.3 milliamps versus 30 milliamps on the G45. There is no comparison here. And also in backup mode, we almost reduced the power consumption by 8, 1.2 microamps versus 8 microamps on SAM9 devices. So as you can see, this is a very low power device with higher performance than the G45 or the X35. So it suits very well for application which needs power efficiency. Okay, so let's move on to the memory support. As I said, when commenting the block diagram, we have two external bus interfaces, a multi-port DDR2 controller, 32-bit data path, supporting DDR2, low power DDR, and DDR2 memories. 4 or 8 bank memories are supported, and in addition to that DDR controller, we have what we call our standard external bus interface to connect, again, PSRAM, NOR flash, NAND flash, FPGA, and so on. So this external bus interface has an 8 or 16-bit data path. Few more information regarding the DDR2 controller. So this is a 32-bit bus width, okay, running at 8 at 133 megahertz, sorry, but you've got what we call the dual pumping feature. So what is the dual pumping? So dual pumping means that you sample data on both falling and rising edge of the clock. So actually it means that you are sampling data at 266 megahertz. Okay? This is the meaning of what we call dual pumping in this slide. I forgot to mention that the maximum supported size is 512 megabytes. Okay? It's quite important because we have the question already many times in the support through the support channel. So maximum supported size is 512 megabytes. We also embedded auto-adaptive pads, okay, thanks to the calibration features. So the auto-adaptive pads reduce overshoots and EMI. Another very interesting features is that there is no need to have external resistors, okay, on the data bus or on the address bus. So this, you save many resistors and you reduce the cost of the bill of material, of course. And we also reduce the power consumption on the IOs thanks to this calibration feature. You've got a slew rate control, differential DQS for low power DDR2, and calibration pins. So those are the main features of the DDR2 controller. Yeah.
I have a question. I don't understand the dual pumping thing because by default DDR means double data rate. In other
Yeah.
So it's sampled on the clock up and down.
Sorry?
Yeah, so it is sampled on both the right
Yeah.
and each of the clock.
Yeah.
What does the dual pumping? What's the difference in?
No, this is what you say. Yeah.
Okay.
Yeah, this is called dual pumping. Yeah. To finish with an overview of the memory support, I would like to share with you a few information regarding the memory calibration process. So depending on the type of memory or DDR memory you use, calibration process is different. So if you use DDR2 or low power DDR, you've got a specific calibration process which is different than the calibration process using low power DDR2. Okay. So first, for DDR2 and low power DDR1 user, you have to add 200 ohm resistors on calibration pins. The second step is to match the serial impedance by configuring a specific field, which is called RDIV. Okay. And then you have to set the calibration timing called, this is a DZQIO field, okay? So this calibration time can be found on the DDR datasheet, okay? Then you have to activate the calibration in a specific register of the DDR2 controller. So this is a quite simple calibration process. As I said, if you use a DDR2 memory, the calibration process is a bit different. First of all, the value of the resistor to be placed on calibration pins is different. Now it's 240 ohms. You still have to configure the serial impedance and the calibration time. But in addition to that, you also need to program the short calibration time. Okay, so this is also a value specified in the low power DDR2 datasheet. And you also have to program the calibration pulse over PVT, so process voltage temperature. Okay, so this is also something which can be found in DDR2 documentation. So I just wanted to highlight the difference because sometimes it's not so clear to understand for users. To finish with this part, this slide is just an example of the implementation of a low power DDR2. If you have a look to the schematics of our evaluation kit, we use a standard, non-low power DDR2 memories. But you will find on our website an application note on how to use and how to connect low power DDR2 low power DDR1 and DDR2 memories. So you can also find these schematics on this dedicated application node. So simply note there are two different voltage references for low power DDR2. As you can see in this slide, there are two power rails, one for the memory and one for the package itself. Let's move on to the security features. As I said, I will not comment too much in details. I just have one single slide on the secure boot mode. Okay, I will comment this feature in another presentation. So basically, you will find a true random number generator embedded in the SAMA5D3, which passes the different requirements specified by the standard mentioned here in this slide. You also have an embedded encryption engine, okay, which will be used in the secure boot process, supporting AES, triple-DELS, and SHA, plus the secure boot solution. Just a few words regarding the secure boot feature. So if you are already familiar with our MPUs, I guess you already know this flow chart. So basically, depending on the state of a pin called BMS, so boot mode select, you will be able to boot from a NOR flash, or you will be able to execute what we call Samba boot, so to boot from the internal ROM. When booting from the internal ROM, you will be able to reprogram the device if you execute what we call Samba monitor, or you will be able to boot from an NVMe memory, non-flash, SD card, EEPROM, serial flash, and so on. So this is our standard boot procedure, and you still have this standard boot procedure on the SAMA5D3. The new feature is that we added in ROM of the product what we call the secure boot. Okay, so the secure boot can be accessed when changing one fuse, which is an OTP one-time programming fuse bit. This bit is the SM bit, okay, for secure mode bit. Simply note that once you set the SM bit to access to the secure boot feature embedded in ROM, this is forever. You cannot come back on the standard boot mode. Okay, but again, I will comment this later in another presentation. So, addition of the secure boot features in ROM. Few words regarding the fuse bit. As I said, you've got 256 one-time programmable bits or fuses. So they are all in what we call the fuse box. So I just highlighted the main fuse bits here in this slide. So this is all related to security features. As you can see, you will find the SM bit, which allows to enable the secure mode, but you also have a fuse bit to disable the BMS pin sampling, or to disable the JTAG, or to make the NVMe programming not possible anymore. So this is really features related to security.
So is there anything special by design in terms of security for the fuse bits or key storage?
Yeah, I will comment this this afternoon. Yeah, in my presentation. So let's move on to connectivity features. So you have embedded in the product 3 full-speed, high-speed ports. So one device controller and one host port controller with an integrated root up and with integrated PHY. Okay. You have I have a diagram of this in the next coming slide. So 2 Ethernet MAC, the standard Ethernet controller. Yeah. Yeah, I will just show you how is it implemented in the next slide. Okay, but if you have a question after that, I will answer. Okay. So two Ethernet MAC, the standard Ethernet controller and the gigabit Ethernet controller, 2 CAN ports. You still have the soft modem interface you can find on the SAMA5D3X series, 3 MCI ports to connect an eMMC or an SD card, and I would say our usual communication ports, so UART, SSC, 2-wire interface with the full support of the I2C standard and the SM bus. This is quite usual on our product, so I will not comment it too much in details. So let's come back to the USB ports. So as you can see in this slide, you've got one high-speed device controller, okay, which shares a transceiver with the host port, so it can be high speed or full speed. Okay, so again with a shared transceiver, as you can see. Does that answer to your question, Gregor?
There was written that one USB host can connect to a hub.
No, the hub is integrated. Yeah, it means that there is a hub integrated. So another new feature comparing to the previous generation of MPUs is that we save 2 pins. So on previous products such as the G45, the full speed and high speed USB pins were separated. So now we share the same pin for both full speed and high speed. So as a consequence, we save 2 pins, as you can see on the right of this slide. And most important, we save the two resistors. So we reduce the cost of the BOM. A few more details regarding the Ethernet controllers now. So the standard Ethernet MAC is quite standard on our MPUs. So you still have the M2E and RM2E mode supported. This is exactly the same port as over SAM9 devices. The new feature is regarding the gigabit Ethernet MAC, so supported the gigabit mode. Okay, we support M2E, GM2E, so gigabit M2E and RG-M2E modes. I will details the connection of the pins just after this slide. But simply note that on this Ethernet controller, the RM2E is not supported, but it's not really a big deal as you have the RG-M2E mode supported. Regarding the new features introduced by the gigabit Ethernet is that now you have a 4K byte FIFO with supporting the jumbo frames. This is, I would say, obvious if you want to increase the performance to support the gigabit the gigabit mode. You've got now an 8-bit data path. It was only 4-bit on our standard Ethernet controller. We also have an MDIO interface for the external fee management. We also support now Wake on LAN. Okay, and the most important is that we are now compliant with the PTP, which is a precision time protocol. I will come back on this in the next coming slide. So basically, this protocol allows to synchronize the clock between a master and several slaves in a network. Okay, but I will details this protocol in few minutes. So this slide just shows the typical connection when using GM2E and M2E connection. Okay, so simply note that when using gigabit mode, you are providing to the external world a 125 megahertz clock signal. So when customer is designing his board, he has to be aware that this is a high speed clock signal. So care must be taken when routing this this signal. This is the same for the RGM2E. You still have to provide to the FI a 125 megahertz signal. Okay, so same rules as previously, but in the RGM2E connection, obviously you don't need you need less signal than the GM2E or M2E. Okay, so let's come back on the precision time protocol. So as I said, this protocol allows to synchronize the clock between a master and different slaves, as you can see in the figure of this slide. So basically, what we do is that we add a timestamp on a frame. Okay, so this protocol is actually based on a timer, a 32-bit timer implemented in hardware, which allows to provide the time and to add a timestamp on an Ethernet frame. So how does the synchronization works? So in few words, there are two steps to synchronize the clock. The first step is the offset correction, and the second step is the delay correction. So firstly, the offset correction. The master will send a synchronized frame to a slave, and then he will send a follow-up frame containing the time in which he sent the first frame to the slave. Okay, so thanks to those two frames, the slave will be able to correct the offset of his clock. Then the second step, the delay correction. So this time the slave sends a delay request frame to the master, and the master will answer to the slave by sending a delay response frame containing the time in which he received the delay request frame from the slave. So thanks to the delay response frame, the slave will be able to correct the delay between his clock and the clock of the master. After the synchronization, the precision between the clock of a master and a slave is below 1 microsecond. Okay.
So do you know why there's asymmetric Ethernet max inside this device?
Can you repeat?
Why there are two different Ethernet max in the device? Why not using, for example, 2 gigabit?
This is a good question. I think it's it was a specification decided by the market. I don't think there is a big difference in size between the gigabit and the standard. Maybe they didn't see a real need to have 2 gigabit ports. I don't know. This is a good question to ask to.
Because the old one eases the migration when you come from ARM products. Of course, you don't
Yeah.
need something different.
Yeah, no, it's really similar. Yeah.
Future proof.
Yeah.
Expected to same kind.
Yeah. Maybe on the next coming product, I'm not sure if they implemented dual gigabit. Yeah. I need to check this.
Isn't the 5 or gigabit Ethernet more expensive? So at the end of the day, it's the implementation cost. It's cheaper to have a.
Yeah, maybe.
In some applications, it's cheaper to have a 100 megabit 5 externally.
Yeah. Yeah, maybe that. Yeah, that's. Yeah, I think that's maybe an explanation. Yeah.
But if you don't need it, isn't it possible to use gigabit Mac with a 105 if you configure the Mac in 100 mode?
Yeah, I don't know.
It should be possible.
So we get rid anyway.
Yeah.
Good question.
So regarding user interface now, so as I said in introduction, we enhanced the LCD controller. You have now 5 layer overlay and a post-processing controller for debug purpose. We still support resistive touchscreen, 4 and 5 wire support. And you find, as usual, I would say, the camera interface, and 2 I2S ports. So let's have a look more in details about the LCD controller. It's seen as a dual master at matrix level. The display size is up to 720p. So I would like to clarify something because I receive, actually I'm behind the 8091 support at atmel.com email address. So I see the question coming from customers or you FAEs. This is the display. The maximum display size is quite confusing for now because in the datasheet it's stated 2K per 2K. Okay, if you have a look to the LCD controller section of the datasheet, the maximum display size is 2K per 2K. So this is actually the maximum display size supported by the LCD controller itself. So which means that if a customer just needs to display a picture from time to time, there is no problem to display pictures in a 2K per 2K format. Okay, but if he wants to do a video, it will practically not be. You will not have a real smooth result with 2K per 2K videos. So for video playing, the maximum resolution is 720p. Okay, so this will be clarified in the next release of the datasheet, but I think it's good to anticipate your next question.
So there is a problem of the bandwidth?
Yeah, yeah, basically, yeah.
This 720p, what is the frame rate then?
This is a good question. We are waiting for benchmarks from the software guys. We still need to benchmarks more in details, and we are waiting for results. Okay. To be honest with you, I am not expecting better result as we have, for example, on the M10, because on the M10 you got an hardware video decoder, so I don't think it will have better figures. But still, we need to have figures. So a 5-layer overlay, an high-end overlay, 2 overlay windows, a base layer, and an hardware cursor layer. In the next coming slide, I have a typical implementation of each overlay. So I will give you an example on how to use each overlay. All overlays have different 2D acceleration graphic capabilities. I will also comment in the next coming slide. You also have embedded in the LCD controller what we call the post-processing controller. This is for debugging purpose. Basically, the purpose of this controller is to take some snapshots of the LCD output in memory before the output is being displayed. Okay, so this is mainly for debug purpose. Another quite important information to share with you is the maximum pixel clock. So the maximum value of the pixel clock is 166 megahertz. So here is the example of the implementation of the different overlay. So overlay, the main interest here is the support of multiple overlay planes. Okay. So for example, you can use the base layer to display a background. So you can see it in blue in this slide. Thanks to the window overlay, you can display, for example, a display. Text, you can display a text, sorry, on top of the background. Okay, you can see it in orange in this slide, or you can display a dock. You can see here. Okay, the hardware cursor, of course, is dedicated to a cursor, and with the high-end HEO layer, you will be able to display videos. In fact, you've got a perfect implementation of the different of the use of the different overlays in the graphical demo coming by default with the kit, the Qt home automation demo. So this is the typical implementation of the different overlay of the LCD controller. Oops. Okay. So as I said, the overlay supports different 2D graphics, 2D acceleration features. All the features supported by each overlay are mentioned in this slide. So basically alpha blending, rotation, scaling, color convention, and chroma upscaling. This brings me to the almost the last part of the presentation, dedicated to control. So this part will be quite fast. There is no big change on the SAMA5D3. Just note that you have a 12-bit ADC with a 12 channel and sampling frequency up to 1 megasample per second with an auto calibration feature. Okay, so you will be able to calibrate the gain. And the 4 and 5 wire resistive touchscreen support. You've got a 16-bit PWM block, two 3-channel 32-bit timers, and in terms of IOs available, you have up to 160 GPIOs. So just to come back briefly on the 12-bit ADC, again, up to 1 megasample per second. The auto calibration allows to calibrate the gain. Okay. The calibration sequence is actually automatic on all enabled channel. Regarding the other features, we improved the overall analog performances, and you still have the multiple trigger sources, so hardware or software.
So is the full speed at full resolution?
Yeah. So that brings me to the last part of this presentation, dedicated to our hardware and software offer. So I have a dedicated presentation on our Linux offer, but simply note that, of course, we provide the evaluation kit, okay, as usual on all our products. Again, it's based on the motherboard, an optional display module, and a CPU module for each derivative of the SAMA5D3 series. Also note that we have partners who provide their own CPU module separately, okay, which are fully supported by the motherboard of our evaluation kit. In terms of operating system, as usual on our MPUs, we provide our free Linux distribution. The distribution available for the SAMA5D3 is based on the kernel 3.6.9. Okay, so we have again a dedicated website for that, Linux for SAM. Okay, so in this website you will be able to retrieve, for example, the binaries of the demo, and there is also a step-by-step description on how to program it. You will be able to retrieve the source code. You will find some links to retrieve all the tools, the compilers, the source code, and so on, to get it started on developing an application in the Linux environment, and plus the user community. So everything can be found in a single entry point, our Linux for SAM website. We also provide for free the Qt SDK. So this is a graphic SDK with widgets. So in the package available on our website or on TimeSys website, you will find the demo, so binaries and source code. You will find the documentation of the Qt SDK plus a training material. Again, I will come back more in details on this on the Qt SDK in another presentation. Regarding Android, so as we did for Linux, we provide a free distribution. So Android for SAM is the single entry point for development with Android on the SAMA5D3. So on Android for SAM, the website is going to be updated in the next coming days, I would say, with an ice cream sandwich, so Android 4.0. So with an ice cream sandwich port on the SAMA5D3. Okay, and just note that this Android demo will be compatible with both display module available on the kit by default, and also with a Max Touch display module, which is bigger and which is a Max Touch display, in fact, provided by one of our partner, PDA. So we call this display module the PDA module, usually. So Linux, free Linux and free Android distribution available, and also the free Qt SDK. We also provide a bare metal C example. So this is available on atmel.com for free. This is what we call the software package, or the soft pack. So suitable for non-operating system users. We provide for now the soft pack for AAR and GNU compilers. Okay. I know some of you will ask the question, is it going to be provided for Kyle? The answer is no, because for now the Kyle compiler is not compatible with Cortex-A5 core. We also provide, in terms of software, what we call the secure boot package. Again, I will come back on this on the other presentation this afternoon. So this is just a set of application notes, secure bootstrap example, and some specific tools to communicate with the secure boot bootloader embedded in the ROM of the SAMA5D3. So more details to come in the other presentation. So let's move on to directly onto the home automation demo. Again, I will come back on this afternoon. Just note that this demo is provided and has been developed by our partner TimeSys. Okay, so this is Qt SDK is actually a widget library. So in this demo, this is just a user interface. You will find a non-screen keyboard, lightning control, thermostat control, a video player also. Another nice feature which has been added in the demo and which is not mentioned in this slide is the support of a camera. So basically you can plug or connect a camera on the USB port, and you will be able to display what the camera is recording on the display module of the evaluation kit. So a nice feature to show to customers. Again, the source code and the binaries are available for free on our Atmel website or on TimeSys. You will work on this demo in a specific hands-on this afternoon. So I hope you will be more familiar with it at the end of the day. Regarding partners, so as I said, TimeSys developed the demo coming by default with the kit, but they also provide their Linux plus Qt commercial offer. Express Logic provide their Fredix BSP. Okay, they ported their BSP on the SAMA5D3. And as I said, several partners such as Mbest, Ronetics, or Shiratech provide their own CPU modules, okay, which are compatible with our with the motherboard of our evaluation kit. And there are still some discussion ongoing between our marketing guys and Micrium, QNX, and so on to extend our software offer around the SAMA5D3. Do you have any question? Okay, so I think I'm done with this presentation. So thank you for your attention.